Hello, everyone. Welcome to Backer Breaks It Down. This is a special episode, right? Because we're working with other trig relationships here, right? So we're talking like the reciprocal functions of cotangent, cosecant, and secant. Okay. And I want to talk about like how can I use a trig ratio. So use one of the trig ratios to find the other 5 trig ratios. Okay, think about that. If I told you one of the 6 trig ratios, right? Each ratio tells us about 2 sides of a right triangle. Think about it. If you know 2 sides of a right triangle, how do you find the 3rd side? Right? Pythagorean theorem. So like we're going to have to use that. So let's check out an example. Okay. Oh, wow. So that was everything we went through in the last episode. All right. So here's the problem that I was talking about. In problem number 2, we are given that secant of angle A is 16/9. So we're given secant. So what that means is that we know that the hypotenuse of our right triangle is 16. And we know that the side adjacent to angle A is 9. Furthermore, we also know cosine, because cosine and secant, they're reciprocals, and you know what that means. Flip to find the recip. So if secant is 16/9, that means cosine is 9/16. And just like that, we only have 4 more trig functions we need to find. Now, the directions say that we should sketch the right triangle described with right angle C. So here is my right triangle. And they said the right angle is angle C, right? I know that the hypotenuse of this triangle is 16, and I know the side adjacent to angle A is 9. Where's angle A? Honestly, pick one of those 2 angles to be angle A. So I'm going to be like, this is angle A, right? The hypotenuse we know is 16. The side adjacent to angle A is 9. We have to use the Pythagorean theorem to find our missing side. Because let's face it, when you know 2, you use Pythagorean theorem to find side 3. So that's what we're going to do. So we're going to be like the leg squared plus the other leg squared is equal to the hypotenuse squared. We're going to do our math and we'll get that x squared is equal to 175. And then we'll take the square root of that and, of course, simplify it. So x is equal to 5 times the square root of 7. So let me label my diagram. Now that I have all 3 sides of my right triangle, I can find my missing ratios, starting with sine. Now we know sine to be the opposite over the hypotenuse. So opposite angle A is that side measuring 5√7. And the hypotenuse, well, it's 16. To find cosecant, we need to flip to find the recip. So if I flip it, I get 16 over 5√7. And now, as you all know, we can't go leaving the square root of 7 in the denominator like that. So we have to rationalize. So we have to multiply the top by the square root of 7. We have to multiply the bottom by the square root of 7. And so our final answer is 16√7 over 35. So what about tangent? So we know tangent to be the opposite over the adjacent. So opposite angle A is that side measuring 5√7. The adjacent is 9. And that's a mighty fine answer for tangent. Cotangent, is the reciprocal. You know what that means? We need to flip to find the recip. So I have 9 over 5 root 7. And oh darn, there's a square root of 7 in the denominator. That's okay, I'll just rationalize it. Seems like the rational thing to do. Ha ha ha. So multiply both by the square root of 7, and on top I get 9 root 7, and on the bottom I get 35. So that's how we can use one trig ratio to find all the others. Sketch the right triangle described, use Pythagorean theorem to find the missing side, and then write your ratios. And that's how Backer breaks it down.